Hello and welcome to another video on semiconductor devices. So today I was talking about reverse biasing. So in the previous video, I talked about diode, how it is being formed, and then reverse biasing. So if you haven't watched that, you can go and watch it in the other video. When it comes to reverse biasing, right, we have a situation whereby if we connect the anode, or which we refer as the P region of the anode, is connected to the negative terminal, and then the N region or the cathode is connected to the positive terminal, as is being shown here. And then also make sure that the bias voltage is greater than the barrier potential of the diode. So when it comes to barrier potential of the diode, we have two kind of barrier potential depending on the kind of semiconductor that is used in the fabrication of the diode. So we have silicon, the barrier potential is usually 0.7 volts, and when it comes to demand, 0.3 volts. Now, when you talk about reverse biasing, like I already indicated, the main thing is that you make sure that the N region of the cathode is connected to the positive terminal, and the P region is connected to the negative terminal. So as a result of this, we are going to have a situation whereby the electrons, which are majority in the N region, force their way to down to the positive terminal, right? And then the holes, which are also majority in the P region, will try to force their way to come to the negative terminal because of what? The force of attraction, right? So based on Coulomb's law, you know that if we have two unlike charges, they try and attract each other, right? Now, as a result of this will lead to the winding of what? The depletion region. So here's the depletion region, right? Depletion region. So as this widens, that prevents electrons from what? Crossing the p-n junction there, so that they can come to the, let's say, positive terminal, right? So we have a situation whereby through the process of what reverse biasing that is taking place, that is leading to the widening of the depletion region that results in no flow of what current across the p-n junction, right? So as a result of that, there is no what current will flow when we are discussing reverse biasing. Now, though we say that usually we don't have current, but we tend to have a small amount of current. It's extremely small amount of current for that matter. And this current is usually due to the minority charge carriers that we have in the diode. As you can see in the P region, we have minority electrons. In the N region, we have what? Minority holes. So meaning that P region that we have, this minority electrons force their way across the depletion region, that is the p-n junction there, into the N region, then come force their way to the positive terminal that we have over here, right? So we have extremely small amount of current that is being created as a result of what? The movement of the minority charge carriers that we have. Now, what we tend to also experience that when it comes to reverse biasing, we can have a situation whereby there is what? Reverse breakdown, right? What that simply means that if we have a situation whereby we have a high reverse bias voltage, right? That is being connected to the diode. This can result in a situation whereby there is extremely speed of what? You have a situation whereby the electrons will try to gain speed, right? In that process, that will result in electrons pushing or knocking out of what? Right? Other electrons out of orbit of the valence bond that is existing between the semiconductors that is used in making or fabricating the diode. So this movement of high speed electrons that knock out other electrons out of orbits will result in the movement of these electrons into the conduction band, hence increasing the flow of current, right? So as a result of this movement of electrons, that effect, right, or that whole process referred to as avalanche effect. So under avalanche effect, you have extremely large amount of current passing through the diode in reverse bias, right? And this is as a result of what we refer to as reverse breakdown, meaning for any given diode is has a reverse breakdown voltage, right? So once the reverse bias voltage exceeds, right, or the reverse voltage exceeds that breakdown voltage, that leads to avalanche effects, whereby you have large amount of current is passing through the diode in reverse biasing, right? So these are some of the parameters that we can talk about regarding reverse biasing. See you in the next video. Bye-bye.